bozze Ukimuana Anainama Anainuka Ananahaya.
Hi, we are Elba
and Andrea.
and welcome to the path walking problem session. So to start, we are going to draw 2020 lines. So these are a bit too many for me, so I will just draw a few lines. So you can draw them as you like.
But can I draw them like this?
No, you can't. Nothing like this. You can only have two lines across the same point. On these lines we are going to have a little snail. How is it going to walk? Now our snail is looking that way, so it's starting to walk in that direction.
And what happens when he arrives here?
Yeah, when it arrives here, it can go left or it can go right.
So it cannot go this way, or it cannot come back.
So it either goes left or right.
So the question is, can the snail walk following these rules and at some point come back to the same point where he started in the opposite direction? So now please stop the video and think, what would you do?
Well, 2020 lines are a bit too many. So why don't we start by drawing 3 lines? There's not many ways to draw 3 lines. So I draw one here, and one here, and another one here. And now we have a little snail that Elba is going to draw. And what happens? Can you try and solve the problem for these 3 lines? Stop the video and try a bit by yourself.
Okay, now what can we do? He arrives at the crossing. He can either turn right, then he goes in this direction and gets lost. So, no solution. Or he turns left, he goes in this direction, again, he arrives to the intersection, he turns to the right, he gets lost, no solution. Or he turns to the left and he continues until the next intersection. Then again he has the same 2 decisions to make. Either he turns this way and he gets lost, or he turns again this way and he comes back to the initial point, but in the same direction as he started. So this is not a solution for our problem. There is no solution.
Since we already tried out the 3 lines, why don't we add another line and we draw 4? There's various ways to draw 4 lines. So we can start, for instance, this way and see what happens when the snail walks around. Or we can try this way. Again, we have 4 lines, but in a bit of a different shape. Or yet another shape with 4 lines. What happens here? So please stop the video now and try with the 3 different shapes. What happens? For this one, we find out that the problem is impossible again, as for the triangle. So the snail can arrive here, and then if he goes right, he gets lost. If he goes left, then he continues on the square. And then here again, if he goes right, he gets lost. And if he goes left, he continues around the square. And here it's the same. So it has to go left. And then here again, if he goes right, he gets lost. But if he goes left, well, he's back to the start, but in the same direction. So this doesn't work. And here we can try some different path, but again we find that it's impossible. So for instance, I can go here and then I go left and then right, and again I'm in the same directions. So you can try other ways and it won't work.
Andrea, I found a solution. Look! It comes back to the same position in the opposite direction.
Are you sure about this?
Yeah. Look, it goes like this, then it turns here, then here, then it turns here,
So do you think Elba is right? I don't agree with Elba, because, well, here you cannot go straight. The snail cannot go straight.
Okay. Did you understand? Now we want to color our plane using different colors. So we want to color one region with one color, and we want to use the following rule. We cannot paint any of the regions that are separated by a line with the same color. So I cannot color this with this color. This is not okay. So I will use another color, blue, for example. But now, can I paint this one blue, Andrea?
I don't think so.
Okay, so I should use another color, so maybe I can use this one. So now I can use this one again, the same as here, because they are not touching each other, and I want to put a special example. So this one is touching this one in this point, but they do not share any line, so I can use the same color. With these rules, can you find a coloring? So this is a possible coloring of the regions, because every two regions separated by a line have two different colors. The question that we have for you is, what is the minimum number of colors that we need to color all our regions following these rules? In this case, we did it with 3 colors. Try to add some lines or use a different configuration, and think if you can also do it with 3 colors. And try to think as well if you can use only 2 or 1 color. Please stop the video now and try yourself.
So we tried again with the same lines, and we managed to do it with 2 colors. How many colors did you use? We think that you can always do it with 2 colors. You can draw whatever lines you want, and there will always be a way to do it with 2. Well, we can look at it together. For instance, you pick any region and you color it, well, let's say we use blue and red. You color it blue, and then, of course, this region has to be red. They cannot be both blue. And also this one and this one, they have to be red. But as Elba showed earlier, this region, which doesn't have any common line with this one, can be blue. And the same for this one. And then now this one has to be red, and this one can also be red. And you keep going like this. And you can also try it with the shapes that you drew. You can try the same rule, and you will see that you can do this coloring with only 2 colors. So now we have our snail back, and this coloring will help us solve the problem of a snail. Maybe you can pause the video and think about it. Do you have any ideas?
So as Andrea told us, the coloring will help us solve the problem. So please try to draw different paths that the snail can make. So here I gave an example. And can you think of the relation between the path and the colors? What do the colors have to do with the path?
So we start here, we are going this direction, and we look around. Let's say that we always look left and see what happens. Well, we look left and we see what color? Blue. When we reach this point, we have to change direction. Here we decided to go left. And when we are on this line, we look left again. What do we see? We see blue.
Wow, it's true.
Yes. So after we turned again, so we go to this line and we look left. What do we see?
Blue.
Blue. And then we move again.
Blue. It's blue all the time. Look, look.
Yeah, exactly. It's blue all the time. So what was our problem? We wanted to go back to the same line here, but in the other direction. But what happens if we are on this line in the other direction and we look left? What color do we see? Red. No matter what we do, no matter where we turn, we look to the left, we always see blue. So is it possible to come back here and have red on the left? Well, it's not. You can try it out with different lines, different parts, and you can color them the same way, and you will see that the color that you have on the left, wherever you go, is always the same. And this means that the snail cannot do what we wanted him to do.
Thanks for listening and for playing. I hope you had fun. Why?